Okay, so let's do homework for chapter 4. So for the homework 4.1.7, it asks us to, it gives us two a set of data represent the temperature and the cricket creeps in 1 minute. So I first plot those data using the matplotlib. And then since we see the data, it's a little bit concave up, so we can change the value, y values down or change the x value up. So in this case, I choose to replace the y value with the square root of y to transform this data. From this, we can say this data is basically follows a linear pattern. So we can determine the function that is square root of y is equal to kx plus b. So if fit the plot, we can get the two regression variables here. Um, and we use this number to plot a linear line here. We can get our equation will be square root of y is equal to 0.2074x minus 3.047. So after we transform this by Gila square of both sides, we can get our final equation will be 0.043x squared minus 264x plus 9.285. So after we plotting those data, we can get a pretty good fit line here in this graph. Let's move forward to the second question, which is 4.2.3. Let me pull up the question here. Okay, so in this question, it's basically the same, using the same set of data as the previous one. It's also about the temperature influence on the cricket creeps in 1 minute. So it asks us to to discuss the appropriateness of using 18 degrees polynomial that process this data. Since we got 19 pair of data, so we use the polyfit to fit those data into 18 degrees polynomial, and we can see that it has some oscillation in the both side. Um, we can get our coefficient here. So I don't think it's very good idea to use the 18-degree polynomial to fit those data, since the data came from just one cricket creeps. So the data would vary a lot. It can have a lot of other influence that can influence the correctness of our data. So as we can see from the from temperature 71 to 72 degrees, the number of the creeps is actually falling down. So it's not very accurate. It has some errors in the graph in the data, so it can affect a lot in our graph, especially in the two endpoint. So I think it's not a very good idea to use the high degree polynomial in our case. Let's jump to the third one, the 4.3.3. Let me pull up the question. 4.3.3. Okay. For this question, it just gives us a set of data. Let us to use the lower order polynomial function to solve it. So this is the data set. So we can calculate those data using the divided difference table. We calculated the divided difference of the y over x using this equation for the first derivative, the first divided difference, and this equation, this function to calculate the d2. So we can get our functions here. So we our tables here. So we can say that the for the D2 the divided difference are all the same for those sets of data, and for D3 these are all become zero. So so it is clearly a quadratic polynomial in our case. So we can use the low order polynomial to solve this question. For the next one, um, it's the question number 10. And so P is the population and the V is the mean velocity. So we have our data set here. So here I defined a function to calculate the divided difference here. So we can get our divided difference in this table. We can see from the table that it's from this one is y and d1, d2, d3. So it's also from d3 all the numbers are become zero or very near to zero. So we can assume a quadratic polynomial would be enough to solve our data set. So as same as above, I calculate the 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 quadratic polynomial of the data. So after I calculate the coefficient of our equation, we get this fitting here. As we can see, this is not a great fit since those point it varies a lot from our line here. I think this because the data are very dense at the beginning part and are very sparse at the following part. So and also but the v values changed only a little bit as the p value increase. So when calculating the divided difference table, since the p values varies a lot, so we can and the v values varies only a little bit, so the divided difference will easily get to zero. So so this fitting is not that good, especially when the p value is in the relatively small range. For the next one, 4.4.3. Let me pop the question here. 4.4.3. So it gives us a set of data and ask us to determine the coefficient of the neutral cubic splines. So we put our data in the NumPy array and scatter the data in our graph. So for this question, I used a module from the SciPy to calculate our coefficient. As I have already list our equations in this part, So we have a lot of equations since we have 1, 2, 3, 4, 5, 6 different segment of our equations. So the equations would become a very large set. So I use the SciPy to do the calculations. So this is our result here. And I have plot our result in the graph. Okay, so this is our homework number chapter 4. Thank you.